we will be doing the coding in Google Colab. Firstly, we will be doing the installation of libraries that are used in computing satellite image statistics. In this tutorial, we will derive zonal statistics from Sentinel-2 images and merge with our Pandas data frame, and also calculate NDWI, that is, water index for flooded areas. We will also learn on how to extract values from raster data and store these values in tabular format, that is, Pandas data frame. Satellite data is dense and uses cells to store values. In many cases, however, we want only a summary of the satellite, that is, raster image converted into a tabular format, which is CSV or Pandas data frame. Satellite images are pixel-wise data, just like any other types of images we have used. In geography and remote sensing terminology, this is called rasters. Raster images mainly consist of satellite images, and rasters consist of a matrix of cells and rows, and each cell or row holds information about the location, such as elevation, temperature and vegetation. This process of deriving table outputs, that is, summary statistics from raster images, is called zonal statistics. Now let us go into the main part of this video tutorial. First, we will start with the data exploration part. Firstly, let us type the codes for installing the libraries and importing the libraries in Google Colab. Now with Rasterio library, we can read the different bands of Sentinel-2 images. In this case, we read bands: 8 as near, 4 as red, 3 as green, and 2 as blue. Let us look at the width and height of the images. Just now, I will be using B4, but we can check if all bands have the same weight and length. We can plot the data to see and explore the satellite images that we have. Here, we will be only plotting band 3. Let us also read the buildings table, which we will use to store the statistical summaries derived from the satellite image. Note that we can use other polygons, like districts, rectangular grids, instead of the building polygons. We will use GeoPandas to read the data. And here are the first 5 rows of the table. We have the geometry column of each building, OSM_I.D, and building columns. We can also plot the buildings on top of the Sentinel-2 images. The buildings are marked as white, and overlaid in the image as shown. The picture shows the extent of the city, that is, residential areas with meandering Shabelle River. Let us now calculate the NDWI values from Sentinel-2 images. To calculate the NDWI values, we use this formula. So, let us calculate using this formula in Rasterio. The NDWI arrays can be plotted with Rasterio. The NDWI plot clearly shows inundated areas near the Shabelle River, that is, blue. And the extent of flooding goes to residential areas. We can save the NDWI arrays as a raster image, so that we can use it later. Now, that we have calculated the NDWI values, it is time to derive statistics from the NDWI raster image and merge to our buildings table. We use rasterio mask functionality to get the cell values from the NDWI raster image using the code that is typed. This is a small function that masks the cell values to our data frame table. We can now derive the values we want. Let us say we are interested in getting the mean values of NDWI for each building. We create a column for that mean_NWI and pass our function to apply the building's geometry and also apply to mean from using numpy. Or get the maximum NDWI values for each building. Our table has two new columns now, the mean_NWI and max_NWI, where we store the mean and max NDWI values for each building. Let us now create a figure and a set of subplots for the axis object, showing mean NDWI. Then, let us create the seaborne displot figure for maximum NDWI. Then, plot the figure of max_NWI through NDWI raster of residential areas in dark green color. Lastly, plot the figure of max_NWI through NDWI raster of residential areas in red color.